This LED fitting has stopped working. The LEDs may still be perfectly serviceable, but when we search for the original driver model, we find nothing useful. This is extremely common with private label and imported LED fittings. The original driver may be discontinued, produced specifically for one customer, or sold under a model number that cannot be traced. The good news is that you may not need the identical driver. What you need is an electrically, thermally, mechanically, and functionally compatible replacement. In this video, we'll show you exactly what to check, what commonly goes wrong, and how to use our free LED driver calculator to produce a short list of potential replacements. A large number of lower-cost LED fittings are manufactured through private label and OEM supply chains in China and other manufacturing regions. When the driver eventually fails, the searching for the original part number may produce no search results. The fitting may have been sold under a different brand, the supplier may no longer carry spare parts, or the driver may have been manufactured specifically for that luminaire. Some drivers have incomplete labels, others use proprietary connectors, unusual dimensions, or a customer-specific part number rather than a searchable manufacturer model. This is not simply a country of manufacture problem. Many world-class LED drivers are manufactured in China. The real problem is traceability, documentation, and continued access to replacement parts. An LED luminaire contains more than the LEDs. It includes a driver, LED light engine, circuit board, thermal system connections, optics and enclosure. LED packages commonly lose output gradually over a long operating life. The driver contains power electronics components that can fail much more suddenly. Inside a typical driver are rectifiers, switching semiconductors, control circuitry and capacitors. These components are exposed to electrical and thermal stress every time the light operates. Common causes of driver failure include excessive temperature inside the fitting. Little addressed fact drivers typically derate at 50 degrees C, operating continuously near maximum power. Mains voltage surges and poor power quality, moisture or condensation. Incompatible dimmers, incorrect LED loading, insufficient ventilation, component quality problems, repeated heating and cooling cycles. Heat is particularly important. The maximum case temperature printed on a driver is not necessarily the temperature that produces its longest life. A driver can remain below its absolute maximum temperature while still running hot enough to considerably shorten its expected operating life. Okay, so do not automatically blame the LED driver. Flickering, delayed starting, random shutdowns, buzzing or a completely dead fitting can indicate driver trouble, but those symptoms do not prove that the driver has failed. The fault could also be an open or damaged LED, a failed LED string, a damaged connector, a broken solder joint, thermal damage to the LED board, faulty control wiring, an incompatible dimmer, or a complete loss of incoming power. Constant current drivers may also behave differently when disconnected from their LED load. A no-load voltage measurement alone may not provide a reliable diagnosis. The fitting should be diagnosed safely before purchasing replacement components. Let's run some checks to try and troubleshoot the issue. The first selection question is whether the original system uses constant current or constant voltage. A constant voltage driver normally shows a fixed output such as 12 volts, 24 volts or 48 volts. These drivers are commonly used with LED strips and modules containing their own current regulation. A constant current driver normally shows a fixed output current such as 350 milliamps, 700 milliamps or 1.4 amps, together with an output voltage range. Constant current drivers are commonly used with Scobias, high-power LEDs and integrated LED light engines. Do not replace a constant current driver with a constant voltage supply or the other way around, merely because the wattage is similar. For a constant current LED system, the current is one of the most important specifications. If the original system operates at 700 milliamps, the replacement would normally be selected or programmed for the same current. Using a higher current can overdrive the LEDs, increase their operating temperature and shorten their life. A lower current may reduce output and can sometimes be used, but only when the LED system and application have been properly evaluated. A constant current driver adjusts its output voltage to maintain the specified current. The operating voltage of the complete LED string must sit inside the driver's constant current voltage range. For example, an LED load operating at approximately 36 volts would not work correctly with a driver whose output range ends at 24 volts. Likewise, the fact that a driver can reach the required voltage does not prove it can deliver the required current and power at that voltage. Power must also be checked. If an LED string requires 102 volts at 1.1 amps, the electrical LED load is approximately 112.2 watts. A 75 watt or 100 watt driver cannot deliver that operating point continuously, even if its voltage range and nominal current appear suitable when viewed separately. The driver must have enough rated output power at the required voltage and current with any necessary allowance for temperature and operating conditions. Also check the AC input range. A driver intended only for 220 to 240 volts may not be suitable for a 120 volt installation for a worldwide product. Look for the exact supported input range rather than assuming that every driver has a universal input.
Next, match the control system.
Possible control methods include phase cut or triac dimming 0 to 10 volt or 1 to 10 volt control, DALI or DALI 2 PWM control, push dim, resistance control, Casambi or another wireless system, programmable output current. A replacement may power the LEDs but still be unsuitable if it does not support the required dimming system. Minimum dimming level and switch-off behavior must also be verified in the individual datasheet. Given all we know and we have not found the original LED driver, we can now use all that to seek out a solution, and we can work from the LED load itself. Open the free Cutter LED driver calculator using the link in the description. First, choose the LED configuration, series, parallel, or constant voltage LED strip. In this example, we have 3 LED modules connected in series. Each module has a forward voltage of approximately 34 volts at an intended operating current of 1.1 amps. We enter a forward voltage of 34 volts per LED module, then the number of modules 3, and finally the operating current of 1.1 amps. The calculator determines that the full string requires approximately 102 volts and consumes 112.2 watts. It then compares that load with driver records from multiple manufacturers. We can filter the results by manufacturer and dimming method and open the relevant data sheets. The calculator provides a shortlist. It does not remove the need to verify the datasheet. For every candidate, confirm. The LED voltage falls inside its operating range. It can deliver the selected current at that voltage. Its rated power is sufficient. Its AC input suits the installation country. Its dimming method is compatible. Its thermal and environmental ratings are suitable, and its dimensions and connections will work. If any one of those requirements is missing, continue to the next candidate. If the original driver is unavailable, do not search only by its model number and do not choose another driver based only on wattage. Identify 1. Constant current or constant voltage, 2. The required output current, 3. The LED operating voltage range, 4. The required output power and AC input supply, and 5. The dimming and control method. Then confirm the physical, thermal, environmental and safety requirements. You can use the free Cutter LED driver calculator to calculate the LED load and compare potential drivers. The calculator and relevant driver categories are linked below. If you need help identifying a replacement, contact us and provide a clear photograph of the complete original label information about the LED module, your country and supply voltage, and the required dimming method.